case where your slope turns out to be positive, and we saw that as you move from left to right, your y value is increased. So the second case would be that you compute the slope using the slope formula and you get a negative number out. So let's look at that case. Our slope formula was m is equal to y2 minus y1 all over x2 minus x1. So I'm going to make up a point now that we're going to be working with. So let's say you're given the ordered pairs 1, 3 and 5, 2. First ordered pair, I see I'm just going to call that x1 and call this, call that y1, call this x2 and call this y2. So going off the formula, our m is going to equal 2 minus 3 over 5 minus 1, right? So this is y2 minus y1, and now we're going to do x2 minus x1, which is going to be 5 minus 1. So 2 minus 3 is negative 1, and 5 minus 1 is 4. So notice we have a negative value now. So, and the slope definition says it's rise over run, so it looks like we're going to rise downwards now, since our slope is negative. But we'll get to look at that on the graph. So let's go ahead and look at that now. Okay, so since we computed our slope to be negative 1/4, let's see how that ties in graphically. So 1, 3, let me plot that out, over 1, up 3, this point here, 5, 2, 1, 2, 3, 4, 5, up 2, would be that point there. Okay, so here's where our two original points were, 1, 3, and 5, 2. So we said in the second case where your slope turns out negative, as you move from left to right, your y value should be decreasing. So here I see that my y value is 3, but as I move from left to right, my y value decreased to 2. So that also matched with what we said. And this could just, if we observe this further, the same thing would have kept happening here. Okay, applying the, just getting tired of the same old color. So applying the rise over run, this time since my slope is negative, I would have to go down 1 to get from this point to this one. So down 1 over 1, 2, 3, 4. So here I went down negative 1, and here I went over positive 4. Hence that would be my slope negative 1/4. But I don't always have to move left to right. I could always move from right to left. So if I wanted to get from this point to that point which I drew earlier, this one here, let's see how that, orange. Let's see how that plays out. So instead of going down 1, I'm going to go up 1. And to get to that point, I'm not going to go to the right 4. I'm going to go to the left 4. So 1, 2, 3, 4. So here I went up positive 1, and here I went over negative 4. So by the slope definition, I had risen 1, but I had gone over negative 4. And here I went down negative 1, but I went over 4. So either way, I still get negative 1/4. It's just, I would just prefer to move from left to right, but I just wanted to show you that either way that you move, you're still going to get negative 1/4. So just like labeling this x1, y1, x2, y2 is arbitrary and it doesn't matter, it's just as long as staying consistent. Moving left to right and right to left is really not important either, as long as you stay consistent. So okay, so since we looked at the second case where you end up getting a negative slope, why don't you guys go ahead and give this a shot? Pause the video and whatnot, and when you guys resume, we'll go over it. Okay, so I'm going to compute the slope of the slope going through these 2 points algebraically, and then we'll look at how that ties in graphically. So again, the slope formula is m is equal to y2 minus y1 all over x2 minus x1. I'm going to move to this side of the board. So I'm just going to stay consistent and call this x1, y1. So this is going to be x1, y1, x2, and y2, and apply the slope formula to it. So m is going to equal, my y2 is 3, y1 is 5, x2 is 3, and x1 is a negative 1. This is a common mistake. Make sure you stay consistent with your negatives. So 3 minus 5 would be a negative 2, and 2 negatives would make a positive. So 3 plus 1 is 4. Letting me know that my slope reduces down to a negative 1/2. Okay, so since we know our slope is negative 1/2 now, let's go ahead and graph that. So our slope was negative 1/2. And before we do that, let's just go ahead and plot these points. So negative 1, 5, negative 1, up 5, 1, 2, 3, 4, 5, right there, and 3, 3. So over 3, up 3, which would be right there. Okay, so these were the original 2 points that I graphed. No, this one here, sorry. So this point here was negative 1, 5, and this point right here was 3, 3. So since I plotted this point here first, and this point second, I can see that my y value starting was 5, and as I moved from left to right, it decreased to 3, so I could see it matches with what we said earlier. And if I want to get from this point to that point, let's apply the slope definition to see if that happens. So from here to get to there, I would have to go down 2. So I went down negative 2, and I'm going over to the right, which is positive 1, 2, 3, 4. So that's a positive 4. It didn't come out to a negative 1/2, but I know that these ratios are going to be equivalent. Going off what slope says, which is rise over run, I had risen 2, and I went over 4. And we know that that simplifies to negative 1/2, which verifies with my slope.